San Francisco, a soaring glass towers meet legendary hills, where cable cars rattle through colorful neighborhoods and the Pacific wind sweeps across the Golden Gate Bridge. It's a symbol of innovation and resilience.
Sister station, KCAL in Los Angeles, was on the air when the shaking started. Take a look.
This is a very strong earthquake.
Pretty strong here.
8:21 here on the air. We're experiencing very strong shaking. Wow. I think we need to get under the desk.
San Francisco, a city where soaring glass towers meet legendary hills, where cable cars rattle through colorful neighborhoods, and the Pacific wind sweeps across the Golden Gate Bridge. It's a symbol of innovation and resilience, built on dreams and, quite literally, on shifting ground. Look beyond the postcard vistas and coffee shops, though, and you'll find a much darker and far more explosive story beneath your feet. Recently, the earth here hasn't just whispered, it's roared. In a startling flurry of seismic activity, over 150 earthquakes, some small, some strong enough to rattle nerves and awake even the lightest sleepers, have rocked the Bay Area in just a handful of days. If you think this is business as usual for California, think again. These aren't merely random tremors. They've been striking in noticeable clusters along fault lines that have held the secrets of centuries right under one of America's most densely populated urban zones. At the center of it all? The San Andreas Fault, 800 miles of pent-up geologic power, threading its way like a sleeping dragon along California's western rim, just offshore west of San Francisco and Daly City. From downtown to the ocean's edge, scientists are keeping a close watch as the ground continues to shift. Historical records and modern data are converging, and concern is growing over the possibility of a long-overdue seismic event. Experts and residents now share the same unnerving question. Are these 150-plus quakes just noise, or are they warning shots before a truly major quake? In this video, we'll delve below the surface of San Francisco, through the fractured maze of tectonic plates, historic patterns, and earth-shaking discoveries. We'll travel through iconic neighborhoods perched above potential danger, reveal the science behind the Bay Area's restless geology, and explore the facts, unvarnished and direct, about what could happen next. Before you dismiss these tremors as background noise, consider, is San Francisco standing at the edge of another seismic reckoning? Chapter 1. Aftershock swarm rattles the Bay. San Francisco was recently jolted awake, not by one, but by more than 150 earthquakes, in a near-constant sequence over just a few days. Some were a soft, almost imperceptible shudder beneath the feet. Others sent windows trembling and nerves tightening, with epicenters lighting up maps in the Pacific just west of San Francisco and Daly City. What does it really mean when so many aftershocks cluster together in such a short period? Are these harmless reminders of California's geology or precursors to something much larger? The answer begins with understanding the difference between routine seismicity and what scientists call a seismic swarm. While California is no stranger to earthquakes, a swarm signals something a bit different from the typical main shock and aftershock sequence. In a swarm, tremors occur in rapid succession, sometimes without a single main event. Each movement redistributes stress along the fault zone and can, at times, trigger further shocks up and down the line. The San Andreas Fault is not just any break in the Earth, it's the boundary between the Pacific and North American plates. These immense sections of the planet's crust slide past each other slowly but inexorably. Most of the time, this movement is slow and steady, but friction locks segments of the fault until, at last, strain is released in a burst of seismic activity. Swarms like the one we're seeing now can be interpreted as the fault's way of readjusting minor imbalances, but sometimes, rarely, they've served as warnings that larger ruptures are ahead. The psychological toll of a series like this is real. Sleepless nights, jittery alarms set off by each rumble, and concern spreading rapidly through communities. Emergency services field repeated calls, some for true structural damage, others just for comforting reassurance. The city is reminded, starkly, of what churns beneath its homes and landmarks. Are these 150-plus tremors simply the ground readjusting, or could they signal movement toward an event of much greater scale? That's a question both scientists and residents are carefully considering. Chapter 2. San Andreas, America's sleeping giant. Imagine the dramatic story beneath the city, a fracture in Earth's crust stretching more than 800 miles, slicing northwestward from the southern deserts, along the mountains and valleys, beneath the neighborhoods and towers of San Francisco, all the way up the coast. The San Andreas Fault is not just famed for its size, but for its prime location and its unparalleled potential risk to millions living nearby. The San Andreas brushes close to San Francisco, running just offshore west of the city and Daly City. Its reach extends from Southern California well past the Bay Area, forming a sharp, deep scar in the landscape. But it is not a solitary threat. California, and especially the Bay Area, is crisscrossed by a complex network of secondary faults, like the Hayward, Calaveras, and Rogers Creek faults. Each contributes to the region's seismic activity and makes local earthquake forecasting one of the highest stakes challenges in geology. Above ground, the evidence can be surprisingly subtle. Gentle bends in rivers, skewed fences in backyards, or curiously diverted roads. When quakes hit, though, that hidden tension is revealed with dramatic effect. The infamous 1957 earthquake serves as an enduring reminder of just how intimately the city's safety is tied to the fault's behavior. San Francisco's neighborhoods are defined by both beauty and risk. In some spaces, Victorian houses perch on reclaimed soils prone to shifting. In others, downtown skyscrapers rest on specially engineered foundations meant to withstand strong ground motion. Neighborhoods like the Sunset or the Marina are built on sandy soils that amplify tremors, while the Rocky Hills offer somewhat more stability, but nowhere is immune. The question remains, how does a city so intricately linked to a geologic power as mighty as the San Andreas prepare for what may come next? Chapter 3. History's Echo, the 1957 San Francisco Quake. Travel back to a foggy March morning in 1957. Life in San Francisco moved as usual until a magnitude 5.7 earthquake struck. Its epicenter, the segment of the San Andreas offshore from Daly City in San Francisco. In mere seconds, the tranquility of the day was shattered. Though moderate by global standards, the 1957 quake left its mark on both infrastructure and memory. Cracks snaked across key roads, glass shattered in city storefronts, and residents braced themselves as the ground quivered. In Daly City, chimneys toppled. In San Francisco, reports of liquefaction emerged from neighborhoods built on sandier ground near Ocean Beach. Even structural icons like the Embarcadero's seawall were impacted, revealing the city's ongoing vulnerability. Why does the 1957 earthquake loom so large in collective memory? Geologists view it as a crucial data point, a reminder that not all significant Bay Area quakes are catastrophic, but all reinforce the ever-present hazard. It's one of several events highlighting just how close danger truly lies. Survivors recall the chaos and the sense of uneasy solidarity that followed. Neighbors checked on each other, first responders braved threats of aftershocks, and many residents slept in parks out of fear of further tremors. Decades later, the quake remains a teaching tool and a warning. The ground beneath the city is always in motion. Each episode, like 1957, fits into a larger pattern, one that scientists and planners must never forget as the next cycle approaches. Chapter 4. Ticking Clock, the 150-year earthquake cycle. To understand what's next for the Bay Area, look to the past. Geologic research has laid out a surprisingly regular rhythm in the earthquake timeline. Over the past 1,400 to 1,500 years, large earthquakes have struck along the southern San Andreas at intervals averaging about 150 years. These are not predictions with pinpoint accuracy, but a sobering estimate grounded in scientific study. This rhythm emerges from layers of sediment, scarred tree rings, fault trenches, and radiocarbon-dated soils, natural records that researchers have painstakingly decoded. Earthquakes of truly destructive magnitude may not occur precisely on schedule, but the overall pattern is hard to ignore. The energy buildup along the San Andreas is relentless, as the Pacific and North American plates strain against each other, barely, until a sudden slip sets the land shaking. San Francisco's historical experience mirrors these cycles. The legendary 1906 earthquake remains the worst in recorded city history, destroying much of the city in both shakes and fire. Since then, scientists have combed through geological archives to learn just what kind of pattern the fault is following. In the East Bay across the peninsula and up into Marin, evidence aligns to suggest the intervals are both meaningful and menacing. Today, the looming question is whether the region is now overdue for its next major rupture. The last truly catastrophic quake was over a century ago, and each passing decade sees tension accumulating beneath the city's feet. According to the U.S. Geological Survey, there is a 72% chance of a magnitude 6.7 earthquake or greater striking the Greater Bay Area before 2043, a number based on deep analysis of the pattern and current conditions. If this pattern continues, could the Bay Area be facing its next historic event within our lifetimes? And can any city truly prepare for the cycle of nature? Chapter 5. Fault lines. Everywhere, the city's subterranean maze. It may be tempting to imagine California's seismic threat as a solitary rift cutting through empty land. But in truth, San Francisco sits atop a tangled maze, a complex, intertwined web of faults running through neighborhoods, beneath parks, streets, and even iconic city landmarks. The San Andreas remains the best known, but it is only one of many. The East Bay's Hayward Fault is widely recognized as one of the country's most threatening urban faults, having produced enormous earthquakes in the past and, by geological reckoning, also due for a major event. The Calaveras, Rogers Creek, San Gregorio, and lesser-known strands contribute to a region where no community is far from a fault trace. This network makes predicting precise danger zones exceptionally challenging. Quakes can ripple through the system, triggering secondary ruptures and compounding the impact. A swarm of earthquakes, like the recent sequence of 150-plus quakes, can reverberate through the network, introducing new stresses just as older ones are being released. City blocks with odd tilts, cracked sidewalks, or subtly out-of-place trees might betray a fracture below. Engineers and seismologists keep close watch, using mapping technology and seismic sensors to track shifts and identify trouble spots. Emergency planners use this data to prioritize upgrades to water lines, gas mains, and foundational support, vital steps in a city where the threat is never far from the surface. No matter which neighborhood you stand in, from the Mission to the Presidio, from Glen Park to the Marina, you are close to a fault. The reality of the Bay Area is that disaster planning must be as multi-layered as the faults themselves. Chapter 6. The Science of Stress, Secrets Beneath the Surface. What happens below ground when hundreds of quakes strike in quick succession? This is the puzzle that scientists work hard to decipher, using every tool at their disposal. Understanding a seismic swarm's implications involves measuring stress accumulation, fault movements, and the transfer of seismic energy throughout the crust. Seismologists employ a vast network of ground sensors that measure the tiniest motions. GPS arrays track how far the Earth itself shifts over time. Each tremor's depth, magnitude, and location are mapped, revealing three-dimensional portraits of stress, energy building in some places, being released in others. Satellite imagery can pick up ground movement as minute as a few millimeters. Computer modeling, using data both recent and historic, is run constantly by research groups and universities. The models look for anomalies, areas where stress doesn't appear to be dissipating but instead is increasing, which could mean a higher risk of a significant event. One emerging area of research uses combinations of historical swarms and modern data to look for indicators of foreshocks, small quakes that sometimes precede large ones, versus aftershocks, smaller tremors following a main event. Swarms do not always precede large earthquakes, but their occurrence means scientists increase attention and warning levels. Authorities and planners rely on this science to adjust hazard maps, update building codes, and inform emergency procedures. With each swarm or unusual seismic event, knowledge grows, even as uncertainty remains. A reminder that, despite advances, the ground holds on to its mysteries. Chapter 7. San Andreas, the unforgiving boundary. Step back and imagine California's geography as a result of titanic forces, not just human vision. The Pacific Plate, ever persistent, moves northwest, nudging the city and its landmarks along. Countering it, the North American Plate stays largely fixed, except where these plates meet. The San Andreas Fault, a restless, grinding boundary. Here, motion is anything but smooth. The plates stick and slip, with decades or centuries of pent-up energy releasing suddenly. Even an inch of movement in a major event can shift entire landscapes, alter river courses, or realigned city blocks. These changes are not always visible, but they are permanent. The shoreline south to Daly City, the bedrock in the Presidio, the soft ground in the marina, each is shaped, layer upon layer, by seismic energy. The land in and around San Francisco is a record book of ancient ruptures, written in stone and sand as much as in stories. San Francisco's golden parks, forested hills, and signature rolling streets all owe their forms, in part, to this clash of geologic giants. Even today, seemingly random features, a street that bends unexpectedly, an old home set at a tilt, a creek that veers from its course, can often be traced back to seismic history, sometimes centuries old. This dynamic boundary isn't just an ever-present risk, it's a defining characteristic of life in California. The Bay Area's constant transformation makes it both inspiring and unstable, a region always in motion. Chapter 8. Risk Reality, the future for San Francisco. San Francisco's beauty and vitality are inseparable from its risk. Living here is, in part, a wager against nature, embracing innovation, resilience, and adaptation in spite of the ever-present seismic threat. Preparedness in the Bay Area has evolved to match this reality. Building codes require new constructions to resist massive shaking, and retrofitting efforts aim to strengthen older structures. Early warning systems now send alerts seconds before shaking arrives, enabling some protective actions. Schools and workplaces routinely run earthquake drills, and disaster preparedness is a regular part of community life. But statistics remain sobering, with the U.S. Geological Survey placing the chance of a magnitude 6.7 or greater quake at 72% before 2043. The Bay Area is not facing an if, but a when. The unique geography, soft soils packed near the bay, steep hills, and vulnerable waterfronts compounds the physical risk. Repeated minor damage is another hazard. When swarms occur, small cracks accumulate. Here a shifted manhole, there a weakened pipe. These add up, testing the city's infrastructure. Families keep disaster kits and discuss emergency plans. Technology companies champion new alert systems but recognize that technology can't hold back the Earth itself. For all the advances, the profound uncertainty remains. Can a city as lively and dynamic as San Francisco ever truly inoculate itself against a disaster that's written into its foundation? Generations have risen to that challenge, and as history suggests, will need to do so again. Chapter 9. Lessons from Ridgecrest, a California reminder. California's web of faults is more than a collection of independent cracks. Large earthquakes that occur miles or even hundreds of miles away can serve as stark reminders and cause for renewed vigilance in the Bay Area. A few years ago, the Ridgecrest earthquake sequence rocked Southern California with thousands of tremors, including two major events. While not directly on the San Andreas, the Ridgecrest quakes illustrated how movement on one fault can redistribute stress and shift risk up and down the state's vast fault network. The lesson from Ridgecrest, emphasized by geologists and planners alike, is one of interconnectedness. While earthquakes are localized, the stress changes they impart may reverberate well beyond their epicenters. For Bay Area scientists and agencies, the Ridgecrest sequence spurred new assessments of emergency preparedness, retrofitting, and public education. Communities across California took note, emergency kits were updated, plans revised, and the importance of science-led planning reinforced. These far-off quakes often serve as wake-up calls, pushing residents to confront preparations for future possibility. California's faults share a narrative, where every event is a thread in a larger story, a constant reminder that the ground beneath all of us is tied together in both history and fate. Chapter 10. The enduring mystery beneath our feet. As this exploration draws to a close, one fact persists above all. San Francisco endures because it learns and adapts with each shock, but it remains defined by the restless earth below. Its hills, waterfronts, and neighborhoods, and its ever-present mythos of resilience and risk, are built on a moving foundation. The recent swarm of over 150 earthquakes isn't just static. It's a reminder from the planet itself that the story here is unfinished. The San Andreas Fault, with its iconic 800-mile span, continues to watch, waiting silently, but never truly resting. Scientists, planners, and the city's millions of residents are all students of this story, never truly certain, but always alert. Though science and technology have advanced, and our ability to predict and prepare has grown, uncertainty remains part of life in the Bay Area. The city's legacy is built as much on its capacity to recover and innovate as on its determination to face the uncertainties below. What do you make of these 150-plus earthquakes? Does the idea of living above shifting ground unsettle or fascinate you? Is it the relentless rhythm of the swarm, the mysterious might of the San Andreas, or the city's resilient spirit that draws your curiosity most? Share your thoughts below, and if you're eager for more journeys into the world's natural mysteries and marvels, don't forget to like, subscribe, and share. Until next time, stay alert, stay curious, and always listen closely to the stories written deep below our feet.